Now, let us discuss this conjugate hyperbola. We know that the standard equation of the hyperbola is given by x square upon a square minus y square by b square is equal to 1. But if you replace 1 by minus 1, then the equation will become x square by a square minus y square by b square is equal to minus 1. Or multiply by minus sign, then you will get y square by b square minus x square by a square is equal to 1. So this is the equation of the conjugate hyperbola. That means this one is conjugate to this original hyperbola x square by a square minus y square by b square is equal to 1. Or it can be defined in this way. Now for a hyperbola x square by a square minus y square by b square, we know that this one a prime a is the transverse axis and b prime is the conjugate axis, where the coordinate of b is this one 0 b and b prime is 0 minus b. Now for the conjugate hyperbola y square by b square minus x square by a square is equal to 1. The transverse axis become the conjugate axis and the conjugate axis become the transverse axis. So for this conjugate hyperbola represented by the equation y square by b square minus x square by a square is equal to 1, the figure of this one will be like this. It will be this one. It cut the y-axis at the point B and B prime. Now this will become the transverse axis for the conjugate hyperbola y square by b square minus x square by a square. BB prime become the transverse axis, and this transverse axis of the original parabola x square by a square minus y square by b square is equal to 1 become the conjugate axis to this y square by b square minus x square by a square is equal to 1. So this is the conjugate hyperbola to the given hyperbola. Now we know that we have discussed the asymptotes. So the asymptotes of the parabola x square by a square minus y square by b square is equal to 1 is this one. Y is equal to b by a into x, and another one is this one, which is represented by y is equal to minus b by a into x. Now you can see from this figure that these asymptotes y is equal to b by a upon b by a into x and y is equal to minus b by a is not only the asymptotes to the given parabola x square by a square minus y square by b square is equal to 1, but it is also asymptote to the conjugate hyperbola. You can see from this figure that it is also asymptotes to this one and also to this. So therefore the asymptotes of the conjugate hyperbola and the conjugate hyperbola and the hyperbola remain the same. Now let us see that if find out what will be the relation between the relation of the eccentricity of the original parabola and the conjugate hyperbola. So now if I take A1 to be the eccentricity of this hyperbola x square by a square minus y square by b square is equal to 1, and the eccentricity of this is E2. So what will be the relation between E1 and E2? So now here we know that the transverse axis of this one, the transverse axis, I'll just write TA, of the original parabola is this one. It is A prime A, where the coordinate of A is this one A 0 and the coordinate of A prime is minus A 0. And the conjugate axis is this one B prime, where the coordinate of B is 0 B and the coordinate of b prime is 0 minus b, that is this one. But for the transverse but for the conjugate hyperbola, the transverse axis, write this one, for this one the conjugate axis is this one a prime and the transverse axis is b prime. So now let us find out. We know that for the hyperbola x square by a square minus y square by b square is equal to 1. We have this relation b square is equal to a square into e square minus 1, e1 square. The relation between the minor axis, the transverse axis, the conjugate axis and the eccentricity is this one. And similarly for the conjugate hyperbola, the relation will be this one. It will be a instead of b square will become a square, and in place of a square will become b square. B square into, if E2 is the eccentricity, so it will be E2 square minus 1. So now we have b square is equal to a square into this 1. So from here we'll see that b square by a square, this is equal to e1 square minus 1. Transfer this 1 to this side, you'll get b square by a square plus 1 is equal to e1 square, and this will give you e1 square is equal to a square plus b square by a square. Now similarly, from this relation of the eccentricity of the conjugate hyperbola with the transverse and the major axis, or transverse and the conjugate axis, will be given by what? You'll get here a square by b square, this is equal to e2 square minus 1, or e2 square is equal to a square by b square plus 1, which gives you e2 square is equal to a square plus b square by b square. So we have got a relation e1 square is equal to a square plus b square by a square, and e2 square is a square plus b square by b square. Now let us find out from here it implies that what is 1 by e1 square, the inverse of this, so it will become a square by a square plus b square, and what is 1 by e2 square, it is equal to b square by a square plus b square. So this implies that 1 by e1 square plus 1 by e2 square is equal to a square by a square plus b square, plus now 1 by e2 square, it is b square by a square plus b square. So now see, the LCM is the same in this case, so it will become a square plus b square by a square plus b square, and this can be cancelled. So finally we have 1 by e1 square plus 1 by e2 square is equal to 1. So this is the relation between the eccentricity E1 of the given hyperbola and the E2, the eccentricity of its conjugate hyperbola. So now let us discuss this, find out what will be the asymptotes to the rectangular hyperbola. Now hyperbola is called a rectangular hyperbola if the value of b is equal to a. So if b is equal to a, then we'll get a rectangular hyperbola. So in this case, in the case of rectangular hyperbola, so this is b prime, but here the coordinate will be 0, a again, and this is 0 minus a. The coordinate of a here is a0, and the coordinate of a prime is minus a0. Here the value of a is same as b, so you will get a rectangular hyperbola. So now for rectangular hyperbola, what will be the equation? X square by a square minus y square by b square is equal to 1 is the standard equation of the hyperbola. But now if you replace a by b, then x square by a square minus y square by a square is equal to 1 will give you the equation of the rectangular hyperbola. And this will imply that x square minus y square is equal to a square. So this is the equation of the rectangular hyperbola. This is the asymptotes. So now here in this case, we know that for the equation of the hyperbola x square by a square minus y square by b square is equal to 1, and its conjugate hyperbola, the asymptotes is given by the equation y is equal to b by a into x, and also y is equal to minus b by a into x. But in the rectangular hyperbola, b is equal to a. So therefore the asymptotes of the rectangular hyperbola will be given by the equation y is equal to 1 is we know that the first one is b by a into x, but b has to be replaced by a, so it will be a by a into x, and another one is y is equal to minus b by a, that is a by a into x. So this will imply that y is equal to x and y is equal to minus x are the equation of the asymptotes to the rectangular hyperbola x square minus y square is equal to a square. And also we know that for our hyperbola x square by a square minus y square by b square is equal to 1, we have that relation b square is equal to a square into e square minus 1. So this will imply that replace b by a square is equal to a square into e square minus 1. Now a square can be cancelled. It gives you 1 is equal to e square minus 1. Transfer this to that side and you get e square is equal to 1 plus 1, which means that e square is equal to 2. So this implies that e is equal to root 2. Therefore, the eccentricity e for the rectangular hyperbola will be given by e is equal to square root of 2. So this will be the eccentricity for a rectangular hyperbola. X square minus y square is equal to a square. Now, let us solve this problem related to the rectangular hyperbola. This one, let us draw it. Now take a point P on this one, hyperbola, whose coordinate, we know that the parametric coordinate of any point on the hyperbola is given by a secant phi, b tan phi. And then take S to be the focus. Let us take S to be this one, AE, 0, and then S prime, it is minus AE 0. So you join this PS and PS prime, where S and S prime are the focus. So here, if we have, let us solve this problem, this one. If P is a point on the rectangular hyperbola, x square minus y square is equal to a square, where C is a center, that is the origin only, and S prime are the two focus, then in that case, SP into S prime P should be equal to CP. This one, CP the whole square. SP into S prime P is equal to CP the whole square. So how will you calculate this one? Now we know that from this, the coordinate of the focus is this one, AE0 and minus AE0 for a hyperbola x square by a square minus y square by b square is equal to 1. But since it is a rectangular hyperbola and we have calculated that the eccentricity of a rectangular hyperbola is equal to root 2. So replace e by root 2. Therefore, the coordinate of this focus for a rectangular hyperbola will be, instead of EA0 and minus EA0, it will be root 2A0 and minus root 2A0. So therefore, what we need to prove is that SP into S prime P is equal to CP square. So calculate this one now. What is SP? By distant formula, we know the coordinate of P and the coordinate of S. That one we know it. But we can also, if you remember that from the standard equation, we have the from the standard equation of the hyperbola, PS, the distance of the point P from the parabola to the ellipse, AE0 is given by the relation EX minus A. That means PS is equal to EX minus A. But what is X in this case? It is A secant theta. So using this one, we can write SP is equal to E times of X, that is A secant theta minus A. So it is A into E secant theta minus 1. Now again, the distance from this point P to another focus, PS prime, it is EX plus A. But what is X? X is this one. X is again A secant theta, the X coordinate of point P. So here it will be S prime P equal to A into E secant theta plus 1. Now find out what is SP into S prime P. This is equal to A into E secant theta minus 1 into A E secant theta plus 1. So this is equal to A into this, A into A will become A square. E secant theta minus 1 into E secant theta plus 1 will be same as E square secant square theta minus 1. And what is the value of E? We know that for a rectangular hyperbola, the value of E is root 2. So it will be A square into root 2 secant square theta minus 1. So let us name this as equation 1. Now next, find out what is this one, C2. What is CP? So CP, you calculate now this CP. CP is equal to what? It will be, using distant formula, it will be A secant theta okay, it will be A secant theta minus, here please correct, E square will become 2 because E is root 2, so E square will become 2. So it is A square into 2 secant theta minus 1. So A secant theta minus 0. The x coordinate of P is A secant theta and the x coordinate of C is 0. And then next, plus B tan theta. But for a rectangular hyperbola, B is equal to A. So therefore, in this case, it will be A. So this will be A. Then A tan theta minus 0, the y coordinate of C the whole square. So this will be A square secant square theta plus A square tan square theta. And this is equal to A square secant square theta plus A square. Now what is tan square theta? Tan square theta is same as secant square theta minus 1 under the square root sign. So this is equal to A square in secant square theta again plus A square secant square theta. So this will give you 2 times of A square secant square theta then minus A square. Take the square of this one, or squaring on both sides, you'll get Cp square is equal to twice A square secant square theta minus A square. So this is A square into secant 2 secant square theta minus 1. So this is equation 2. Now just check, compare this equation 1. Equation Sp into S prime P is A square into 2 secant square theta minus 1. And again, we get Cp square is equal to A square into 2 secant square theta minus 1. This is equation 2. So from 1 and 2, we conclude that Sp into S prime P is equal to Cp square. Now, I hope that it is clear now by the definition of a conjugate hyperbola and what will be the definition of rectangular hyperbola and what will be the asymptotes to the rectangular hyperbola. You please go through again. If it is not clear, and you please let me know.